Hey everyone, thanks for coming today to today's webinar. This is running cost-effective batch workloads with AWS Batch and Amazon EC2 Spot instances. My name is Chad Schmutzer. I'm a solutions architect with AWS focused on EC2 Spot instances. And so today, what we'll be doing here in the agenda is to give an overview of what Amazon EC2 Spot instances are to get a good level set. We'll talk briefly about what is batch computing and sort of put a definition to that. We'll cover AWS Batch overview and concepts, right, to get you familiar with what AWS Batch is and can do. We'll review some use cases that are really great use cases for AWS Batch, and then we'll do a demo or two, depending on how much time we have here to run through some demos. But I really like to spend time on demos. I think it's a better use of your time if you can see things in action, and so I've built out a couple demos that are also available for you to go through in your own time on GitHub, and I'll provide the links there. And then we'll spend a few minutes doing some Q&A. We do have moderators moderating the Q&A room, or the chat room, if you will, so you can feel free to post your questions in there. We will do our best to answer those in real time, and then at the end we'll save, like I said, a couple extra minutes to answer any questions that are outstanding as we go through this. And so, I hope if you're new to AWS, this is a good introduction. If you're familiar with AWS or maybe haven't used Spot instances before or haven't used Batch before, I hope there's something in this for everybody, and that you can take away some new ideas and understand how you can really get some really cost-effective workloads done by combining AWS Batch with EC2 Spot instances. All right, so let's just jump into this. You're probably familiar with the first two purchasing models that you see on this screen, right? On the left, we have on demand. That's where you pay for the compute capacity by the second with no long-term commitments. Good for spiky workloads or while you're still defining your workloads. Once you've been able to define your workloads that will be running for longer periods of time, really the most cost-effective way to lock in those purchases would be with reserved instances, and in exchange for a 1 or a 3 year commitment, you can receive significant discounts off of the on-demand prices, and reserved instances are great for committed steady state usage. Well, the third purchasing option we have on the right are what we call spot instances, and this is where we give you access to our spare capacity with the ability to achieve savings up to 90% off of the on-demand prices. And spot instances are great for all kinds of workloads. Fault-tolerant, flexible, stateless workloads by far are the best fits. But we'll talk a little bit here about how spot instances are a natural fit for batch workloads. And again, really, what are spot instances? Again, spare EC2 capacity with a very simple rule, right? And that rule is that AWS can reclaim that capacity with a 2-minute warning if we need to take that capacity back. But spot instances come with some really great features, right? The first being low cost. Again, typically, you can achieve savings of 70 to 90% off of the on-demand price just by replacing Spot, your on-demand workloads with Spot, right? So a very easy win to get that low cost for the EC2 capacity. Faster results, right? We like to say, if you can throw more compute capacity at your workload and get more work done faster, which is often the case with batch workloads. Spot is saving you so much. It's really quite easy to scale up above and beyond what you normally would be able to scale with the on-demand purchasing model. Very easy to access. You can launch Spot instances directly from other services, through multiple APIs. We offer a lot of flexibility around how you can request Spot instances. And then finally, there's a lot of resource flexibility that come in hand with using Spot, where you can use different instance types and sizes and really tap into the architecture and the compute capacity that you need for your own workloads. Right, and again, Spot instances are really spare compute capacity at scale. Spot is available for all EC2 instance types and is available in all public regions and availability zones. and Spot will be coming soon there for GovCloud for those of you that are anxious to get Spot into GovCloud. So you know that there's a lot of spare capacity as we have our global resources, and it's all there for you to tap into as you need to for your particular workload. So one thing that's important to understand when it comes to using Spot instances is something called Spot pools, right? And so what a Spot pool is really defining it is really the fact that each instance family, each instance size in every availability zone is a separate Spot pool, right? So as we add more and more new instance types, families, and sizes, right? We've got more and more spare capacity that is growing, right, for you to tap into. And so, again, Spot's available for all instance types. So whether you're looking for the latest generation or previous generations, just understand that you want to think about how many different pools you can tap into to achieve your scale and cost savings when it comes to utilizing Spot instances. And the right graphic here is really showing driving one of the best practices around Spot usage, which is instance flexibility and diversification, right? So the fact that you want to think about how many different pools can I tap into? How can I diversify my workload in order to achieve, what I'm trying to achieve in terms of compute? And so here we can see, we're mixing and matching C's and M's and R's, and also mixing and matching sizes. So, R4 8X and R2X, R4 2X. Thinking about, how can I just request all these different sizes and allow my work to get done on top of the fundamental platform of compute. So, I did say one of the best practices for utilizing Spot is being flexible. And so in this case, what does it mean to be instance flexible, right? So first of all, there's instance size, right? So an M4 extra large capacity is actually different from M4 large capacity in our data centers. So what's important is for you to think about how many different sizes can I use efficiently in my own workload, right? And likewise, instance families are also different pools of capacity. So if you think about it, if you can use a C4 large, you can almost certainly also use an M4 large and an R4 large, right? So they have the same number of virtual CPUs. They just come with a bit of extra memory. And availability zones, right? So each availability zone consists of one or more discrete data centers. And again, so US East 2A is different from US 2B capacity, as an example. So if your application can use multiple availability zones, by all means, do it. So we also provide tools for you to utilize to deploy your Spot resources, right? And so one of those tools is called EC2 Spot Fleet. And the job of EC2 Spot Fleet is to automate the management of your Spot instances. You simply tell Spot Fleet how much capacity you need, and then Fleet goes off and does the rest. So it's a single API call to launch, single or thousands of Spot instances and even on-demand instances in the same request. You can maintain that capacity, you can scale it up, you can scale it down based on metrics that are important to you. You can also tell Spot Fleet to optimize on price versus availability, right? So it helps you find the lowest priced horsepower that works for you, or it helps diversify to increase availability. You can also do things like attach your Spot instances in a Spot Fleet to a load balancer. And then finally, it allows you to customize based on your own application requirements. You can create units that are relevant to what you need, whether they're virtual CPUs or memory units or whatnot, but you can feed all this information to Spot Fleet, and it can go figure out how much capacity to provision for your particular workload. Spot is great for many different types of use cases. On this slide, I have big data, containers and dev test, stateless web services, but really the workload that we're going to focus on today is around HPC and batch. So, as we go through this, don't think Spot is only for batch or HPC. It's a great fit, and it's what we're focusing on today. But, by all means, think about other areas where Spot can also be a very natural fit in your own workloads, in your own, in the diversified sets of workloads and architectures that you have in your own environment. All right, so let's really jump into this. So what exactly is batch computing, and how do we define that? So batch computing is really the ability to run jobs asynchronously and automatically across one or more computers, right? Fundamental definition of that. And sometimes jobs may have dependencies, so making the sequencing and scheduling of multiple jobs complex and challenging, right? So sometimes, a secondary job will have a dependency on our first job. So the order that these jobs complete is important, and so it's important that you have a scheduler that can handle this kind of thing. So how does batch computing work in the cloud, right? So with AWS, right, you often have different requirements on your end. You may have batch workloads that are very CPU intensive or RAM intensive or IO intensive, right? Or maybe high storage. Possible that you need GPUs or FPGAs, right? So your batch workloads really are what are going to drive the definitions and the requirements from what kind of compute capacity and underlying instance types you'll be needing, right? So the good news is that AWS has a varying amount of instance types that map naturally back to the different requirements that you may have for your job. So on the CPU side, we have the C family, right, which are CPU specific instance types. And on the memory side, we have all the R family, which have a higher ratio of memory to CPU. We have the I family, which are designed to provide very high I/O for your given workloads on top of these instance types. Storage heavy workloads where you have a lot of storage, need to have a heavy amount of storage available to you for your batch computing workloads. The D family provides that. GPUs, right? So you may need to do machine learning or deep learning or things that really have great speed up available to them by utilizing GPUs. And so we have the P families for that, and floating point calculations. We have the F series. So again, the great news here is that all of these instance types are available as spot instances. And so point here, right, we've got you covered, right? So no matter what your particular requirements are for your batch environments and your batch computing needs are, you have the ability to tap into the different underlying instance types for your particular needs. Right, so still, batch computing could still be a bit easier, right? So if you were to build out a batch computing environment yourself, these are some of the AWS components that you probably would be tapping into, right? So obviously you need some compute. So EC2, it's a best suggestion to use spot instances. So Spot Fleet is a great tool to use there. You probably want your area, your environment to scale up and scale down automatically. So you're going to need auto scaling. You need probably a queuing system, CloudWatch, Lambda functions, and S3 and Dynamo, et cetera, et cetera. So these are all services that by all means you can use to build out your environments, or in particular around batch computing, and we have examples of how to do this all on your own. However, it just so happens we have a service called AWS Batch, right? And AWS Batch is a fully managed, batch computing environment service that really allows you to spin up your batch workloads with no software to install or servers to manage. AWS Batch is able to provision, manage, and scale your infrastructure all for you directly within the environment, right? It's also heavily integrated with other AWS services, native integration with AWS Platform. AWS Batch can easily and securely interact with other services such as S3, DynamoDB, recognition, et cetera, all from just within the service itself. And one of the very important things is that it's cost optimized around its resource provisioning model, right? So AWS Batch will automatically provision compute resources that are tailored to the needs of your jobs using Amazon EC2 and on-demand and EC2 spot instances, right? So it's got the cost optimization built into it around the provisioning model, and we'll talk a little bit more about here as we go through this. So again, AWS Batch is fully managed, right? And it handles, in the managed sense, all of the typical batch primitives, right? And what that allows you to do is it allows you to focus on your applications, right? So if these applications are simply shell scripts or they're executable, Linux executables or Docker images, and likewise, the resource requirements for all of these things. It lets you focus on all of that versus trying to figure all of that out. And point being, AWS Batch really just takes care of the rest, right? So again, we want you to focus on your particular workload, what you need to get done, and then let us handle the provisioning and the maintaining of this environment for you. So AWS Batch has a few concepts, right? So we'll just run through these real quick. So it has the concept, the concept of a job, job definitions, job queues, compute environments, and a scheduler, right? And so the compute environments are really what you know, the underlying compute capacity that is being spun up to run your jobs. And in order to run those jobs, you create a job queue, and you can provide different parameters around those queues, priorities, etc. And then you can create job definitions, which really define you know, what needs to happen for a particular job or a set of jobs. And then those are all fed to the scheduler, which then ultimately figures everything out. It figures out, you know, where should I run these jobs? What are required to run these jobs? Do I need more or less compute capacity? Should I spin up more or less? You know, how do I handle, you know, the order of the jobs that are run if there are dependencies, et cetera, et cetera. So again, breaking this down, jobs are a unit of work executed by AWS Batch as a containerized application running on Amazon EC2. So containerized jobs can reference a container image, a command, and parameters, or users can simply provide a zip file containing their app, and we'll run it you know, on a default Amazon Linux container, right? And so it's very quite simple to simply submit a job. And you can see here, here's an example command line referencing submitting a new Genomics job into AWS Batch. It's also quite easy to run jobs massively in parallel with AWS Batch, right? So users can do that two different ways. They can submit a large number of independent simple jobs, or you can run an array of jobs that runs many copies of an application against an array of elements, right? So array jobs are an efficient way to run lots of different things: Monte Carlo simulations, processing a large collection of objects, and in my demo, we'll actually run through an example process here. But again, point being, if you can set your jobs up in an array fashion, you know, Batch is designed to take that into consideration when it's spinning up your environment and your jobs. So there are also workflows and job dependencies, right? So I know there's a lot going on here in this slide, but this is an example of different job types and the underlying dependencies that they may have throughout the workflow, right? So for example, you may have sequential jobs, right? So jobs that you know, can only be executed once the previous step is done. You may have jobs that will then spawn off parallel jobs that then have other dependencies above them or below them. So and these can all come back together and then spread back out. But the point being is that you know, Batch is designed to handle this both from a sequencing perspective as well as a priority perspective. So in terms of workflow, pipeline, and job dependencies, jobs can express a dependency on the successful completion of other jobs or specific elements of an array job, right? So you can use your preferred workflow engine and language to submit these jobs, and then you can allow Batch to you know, figure it out and to execute these jobs. So you know, the whole point here being, look, let's feed in what my underlying requirements are and the ordering requirements are, and then we'll let the Batch scheduler identify inter-job dependencies and figure all of this out automatically and execute all of these jobs in the order that they need to be done to get your larger workflow done. So again, all of this is built into Batch. So the next definition are job definitions, and so if you're familiar with the Elastic Container Service ECS, job definitions are very similar to ECS task definitions. They essentially specify how jobs are to be run inside of AWS Batch. While each job must reference a job definition, many of the parameters can be overridden at job submission. Some of the attributes that are specified in a job definition include an IAM role associated with the job. So if you need to give your job permissions to do something like copy data from S3 or push data to S3 or submit something to a queue or execute a Lambda function or push data to a database, you can associate a role with the job so that you can give very fine-grained permissions to the individual jobs that are being executed. You can also tie in vCPU and memory requirements to jobs so that when the container is deployed on the instances, it understands the resource requirements for this particular job to be able to execute. If you need to mount extra volumes in order to read-write data or to mount some sort of a centralized file system, an EFS volume or something like this, you can provide additional mount points. You can also do things like include container properties and environment variables that can be passed to additional jobs that are being run within your environment. So here's an example at the bottom here of AWS Batch registering a new job definition. You can feed it a JSON formatted definition file, and you can then register that job definition with the AWS Batch service. So another component of AWS Batch are job queues, and jobs are submitted to a job queue, and jobs will reside in that queue until they are able to be scheduled to a compute resource. Information related to completed jobs persist in the queue for 24 hours. So you can go back and reference the status of jobs in the job queue for up to 24 hours after the job has been submitted. And so again, here's another example of AWS Batch creating a new job queue from the CLI. You can define a name, you can give it a priority, and then you can associate that job queue with a specific compute environment within your AWS Batch service. All right, so what exactly are compute environments? So job queues are mapped to one or more compute environments containing the underlying EC2 instances used to run the containerized batch jobs. So there's two different types of compute environments, managed and unmanaged. So with managed compute environments, you're able to define and describe your business requirements. So that means instance types, min-max desired virtual CPUs, and how you'd like to use spot instances, for example. And then AWS Batch will launch and scale the resources on your behalf for you automatically. So you can choose specific instance types. For example, you can say, I would like to use C4 8 extra large, or you can specify families, instance families, let's say C4s, M4s, R3s, or you can simply choose optimal, and AWS Batch will launch appropriate sized instances from our more modern instance family. So depending on how much you want to tweak and configure your environments is completely up to you, but all this can be done through the managed compute environment. Alternatively, you can launch and manage your own resources within an unmanaged compute environment. And so in this case, what you do is you can scale up your own environment and then associate those instances with the batch service. And so in this case, your instances need to include the ECS agent and need to run supported versions of Linux and Docker. In this case, AWS Batch will create an Amazon ECS cluster which can then accept the instances that you launch, right? So in that place, the jobs can be scheduled to your computer environment as soon as the instances are healthy and are registered with the ECS agent. And so in our demo, we'll actually walk through this. We'll actually walk through spinning up an unmanaged computer environment and then having that register with the ECS cluster, which is associated with the unmanaged batch computer environment. So finally, in terms of batch concepts, we have the scheduler, right? And this is a really critical part of the whole batch service itself, right? And so what this is the scheduler's job is to evaluate when, where, and how to run jobs that have been submitted to a job queue. Jobs will run in approximately the order in which they are submitted as long as all dependencies on other jobs have been met, right? So if you do set dependencies, that will more or less define the ordering. if a job has been specified that it cannot run until a dependency needs to be in place. Otherwise, they'll simply run approximately in the order in which they're submitted. So when jobs are submitted to a job queue, they can have the following states, right? So first they're submitted, right? That means they've been accepted into the queue but have not yet been evaluated for execution. After that, they'll move into a pending state, right? So this is where your job has dependencies on other jobs which have not yet completed, right? So that you can see them sitting in the pending state, especially if there's a dependency that needs to be fulfilled. Once the job has been evaluated by the scheduler and is ready to run, it will move into the runnable state. Finally, a job will move into the starting state, and that at that point, the job is in the process of being scheduled to a compute resource. So that means the job that you've submitted and requested is now getting ready to be spun up and is actively being spun up on a compute resource within your compute environment. Then it goes into a running state, right? This means the container has been deployed onto the instance and your job has been executed and is currently running. And then succeeded, right? So once your job has finished, it will exit with code 0, which means job finished and the job has succeeded. If for whatever reason your job finishes with a non-zero exit code or was canceled or terminated, in that case, instead of going into the succeeded state, it would go into the failed state. And at that point, you would be able to go back and look at the logs and understand, what may have happened with your job, if you don't quite understand why it exited. There are also lots of actions that you can take on each of these items here. So in terms of jobs, you can submit a job, list, describe, cancel, and terminate a job. In terms of job definitions, register, describe, and deregister around your job queues, right? So if you want to understand the existing queuing environment or create a new one, you can create, describe, update, or even delete if you need to. And then with your compute environments themselves, Batch allows you to create a new computer environment, describe your existing compute environments, update your computer environments if you want to update parameters, or delete computer environments if you're finished with a particular set of resources within a compute environment. So what happens when you cancel a job or terminate a job? Well, you want to have it. You want to track why that happened, right? So these require a reason, which is viewable via describe jobs, right? So on the bottom here, we're showing, look, if you want to cancel a job, let's tell the service what happened, why it's being canceled. So in this case, you're passing a reason, which is, oops, submitted to a wrong queue. So in the case where you cancel a job, the job gets marked. Jobs that are not yet starting or failed get marked as canceled. Jobs that are canceled that are currently waiting in the queue go to terminate. So you can stop those jobs, I should say. So that really stops jobs that are in a starting or running state and then transitions them to a failed state. All right, so batch pricing. The fantastic news here is that there's no charge for AWS Batch itself. So you only pay for the underlying resources that you consume, right? So again, just using the batch as AWS Batch as your orchestration tool doesn't cost you anything. The only thing that you'll be paying for are the resources that batch spins up or that you spin up in an unmanaged environment and attach those. In either case, again, the compute resources and all the other associated resources that come along with the environment, but not the batch service itself. So, within the AWS ecosystem, AWS Batch is really one of many complementary services. So there are also other services such as CFN cluster or CloudFormation cluster, which is an elastic HPC cluster that is ideal for tightly coupled latency-sensitive applications, or when customers would like to use an OSS or a commercial job scheduler. When you want to bring your own scheduler or a commercial job scheduler, CFN cluster is really the way to go in that situation. There's also glue and data pipeline, which are ETL services for that help with to and from relational databases with known schemas. There's Amazon EMR, Elastic MapReduce, which is managed MapReduce clusters running Hadoop, Spark for large-scale data processing. There's Elasticsearch, allows you to perform web crawling on social media sites, for example, and populate results to a searchable data set. There's Lambda, right? So this is a serverless environment for running short duration functions without provisioning or managing servers. And then there's step functions, so, lots of different ways to design and orchestrate workflows with support for branching and calling out to other AWS services. So again, think of Batch as just one of the pieces to lots of many different complementary services that AWS provides. So let's walk through some ideas for inspiration here on how we can think about using Batch. So this is really a very typical AWS Batch job architecture, right? So on the left-hand side, we have our job definitions. We've defined our roles. We provide our application image or our Docker image and any other job resource requirements and other parameters that we need. We then have input files, and we have S3 events that would trigger Lambda functions to submit new batch jobs once those input files have been dropped into the S3 bucket. Those jobs then go into a queue of runnable jobs. The AWS Batch scheduler picks them up and runs them in your AWS Batch compute environments, and then the batch compute environments and the jobs ultimately output the job or the job data and status, right? And that could go into something like an S3 bucket or a DynamoDB table or a relational database, et cetera. Whatever it is you need to do to store your jobs, you store the data, the output of your jobs long term. So, very common AWS batch configurations include things like cost optimized resources, right? So minimizing operational overhead, work that can happen at any time over a multi-hour period, sort of time-insensitive workflows, or Monte Carlo simulations, or bulk loan application processing. Resource optimized, budget, if you have budget constraints, multiple job queues, priorities, sharing compute environments, existing compute resources that are already available or underutilized. If you have reserved instances, for example, you can spin those up and attach them to your batch environments. And then for time optimized workflows, where you have very firm deadlines, you can change queues with primary compute environments for using reserved instances or fixed capacity, or secondary workloads with being powered by Spot. So again, lots of different ways to achieve your different objectives depending on what you need. DNA sequencing is a good example of a batch use case, right? Where we would send raw reads from genome sequencers into AWS. Lambda functions would pick those up and respond to them to the arrival of that data and submit batch jobs. Batch then picks them up, configures resources, and the scheduler figures out when to run your secondary analysis workflow. That data can then the output can then be fed into a big data analytics workflow for additional mapping and alignment, etc. And then you want to store the output into long-term storage to archive your results. So maybe a combination of S3 and Glacier, for example. You can also do this with an unmanaged compute environment, right? So in this case, what this is showing is spinning up your own compute environment and then associating it with AWS Batch and setting up your own custom automatic scaling to scale up and down the resources depending on, in this case, how many runnable jobs are in the queue. And so we have maybe a Lambda function that's polling for that information, then feeding that into a custom CloudWatch metric. And then we set up alarms around that custom CloudWatch metric to automatically scale up and down the ECS environment in the unmanaged compute environment. Computational chemistry, right? In this case, we've got our files stored as AWS data. We send those small molecules and drug targets into AWS and just store them in S3. Batch then picks them up. You configure the resources and schedule, when to run your high throughput screens. That the results are then moved into an environment for additional big data analysis. You can complete your compound screening And then finally, store the results into again, long-term storage for either a further analysis or long-term storage. Um, media, encoding, transcoding, right? Lots of options for ingesting content and job catalog, submitting those jobs into AWS Batch for transcoding. Those jobs are then delivered ultimately and then executed in containers without having to worry about instance types and invoking licenses, et cetera, et cetera. All this is taken care of for you with the asset manager, et cetera, that you can tie into the resources. So animation and visual effects rendering. Again, lots of options here. Maybe you have graphic artists creating blueprints. These are then scheduled as render or processing jobs in the pipeline manager. You then submit and render those jobs into AWS Batch. Prefetch of content from S3 or on-prem locations, and then distribute it out across the rendering farm for effectively managing dependencies. And then finally, writing those back into S3 or another output location, depending on what you need. Financial trading analytics, in this case, taking AWS data, your files, your apps, storing those into S3, taking those and then running AWS batch jobs to analyze the data, maybe putting it into additional workload areas for additional big data analytics, and then finally, again, moving those into storage. So you kind of see a trend here for how this process works. All right, so let's go ahead and jump into a demo here. Let me switch over to my console. So I've got a couple of demos stashed in this GitHub repo, and this GitHub repo will be made available to you as links at the end of this slide, at the end of this deck here. So again, don't worry about trying to grab it off my screen right here. We'll have the link available. So the first demo that I'll show you is actually understanding how we would spin up a compute environment. It's actually outside of AWS Batch. What it's looking at and what it's using is really spinning up a spot fleet that is being fed jobs, or what it's doing is it's pulling jobs from an SQS queue and it's executing these jobs on the instances within a spot fleet. And then it's taking those jobs, running those jobs, checking them out of the SQS queue, running the jobs, and then submitting the output back into the source, which is an S3 bucket, and then it's taking and then deleting that job from the queue. So what I'm trying to show here is this is how you would typically build out an environment without using AWS Batch, and so showing you the different things that you need to put into this, right? So you need, for example, a spot fleet, you need an SQS queue, you need automatic scaling, you need an S3 bucket, etc. So what I've done here is I've created all of this environment as a CloudFormation template, and by all means, do take a moment to spin up this CloudFormation template when you have a moment and kind of understand what it's doing here. But basically, what we're doing is we're setting up an SQS queue, we're setting up a spot fleet, an S3 bucket, and then we're setting up corresponding requirements to power this environment. So we have a virtual private cloud, subnets within our VPC and availability zone mappings. We have our spot fleet itself. We have all of the IAM roles and policies that are associated with the instances in that spot fleet. We have the scaling policy set up to automatically scale up and scale down our spot fleet based on the amount of work that is sitting in the SQS queue. So we have all these permissions and everything set up for you automatically when you launch this CloudFormation template. And the whole idea here is that, again, it's quite cost effective to power this whole environment with an EC2 spot fleet, right? So let me just kind of walk through what this looked like. So I've already launched this environment, and I just called it batch here, but we can see that this environment has been spun up, and the outputs that it's showing me are an S3 bucket ID. And so going back to my GitHub repo, let me show you the workers that are running on each of the instances. So each of the instances are basically polling from an SQS queue looking for work to do. And when they find that work to do, they check that work out of the queue with the AWS CLI. They download that work. And in this case, the work here is that we want to convert images into PDFs, right? So a very simple use case, but what we're doing is we're taking an image, we're downloading that image from an S3 bucket to the local machine. We're then converting that image from the current image format that it's in into a PDF, and then we're copying that image back into the S3 bucket. So it's a quite simple process, but again, sort of outlines the fundamental concept of just getting some amount of work done that's sitting in a queue. So how we know how much work actually gets submitted into a job queue happens through Lambda. And so what happens is a Lambda function will come along and get triggered every time a new object gets dropped into this bucket. And every time a new object gets dropped into a bucket, the Lambda function will automatically add a new item into the SQS queue. So let's go ahead and just do this. Let me browse to my S3 console and find the bucket that we're talking about here. So this bucket is called batch, and I can see the name of this bucket here in the outputs of my CloudFormation. So let me just drop an image into this bucket here. So let me click the upload button. I've got an image here, happens to be the icon for Spot instances. So what I've done is I've dropped this image into this bucket. Behind the scenes, Lambda added a new entry into the SQS queue that told it there was some work to be done, and I have the pollers running on my Spot instances that are looking for work to be done. So if I hit refresh here, so we can see that one of my instances checked that job out. It converted this image, from its current format, which is a PNG, and it basically converted it into a PDF. And we can see that this PDF is also the same image here that it converted for me. So it did all of this automatically, and I did all of this, sort of behind the scenes using Lambda functions, SQS, and a Spot fleet. All right, so let's do a little bit more advanced demonstration here now, which is to utilize AWS Batch to do sort of a similar work process, but at a bigger scale. So I also have a CloudFormation template that walks through this here. So what we're going to do here is find the AWS Batch, EC2 Spot AWS Batch, and directory, and in here I also have a CloudFormation template. And what this CloudFormation template is doing is it's actually spinning up an EC2 autoscale group, and it's associating that EC2 autoscale group with my unmanaged batch compute environment, right? And so the point here is that batch is very flexible. So I can either tell batch to spin up my compute resources, or I can spin up my own compute resources and then associate it with my batch compute environment, my unmanaged compute environment with the batch service. And so this CloudFormation template also has all of the built-out roles, policies, and permissions associated with it. It sets up the job queue within my batch environment. And like I mentioned before, it sets up an EC2 autoscale group. It uses EC2 launch templates to define that we would like to use Spot instances as the instance types driving this environment. And then finally, you can see within user data, what I'm doing here is I'm actually registering through user data the instances that get spun up through the autoscale group with the ECS cluster that's been configured as a part of my unmanaged batch compute environment, right? So I also have spun up this environment within my AWS console. You can see here all of the resources that it spun up. So what I also did was I also built a container, and I'll show you this Docker file for this container. This container is quite simple. what it does is it starts from the Amazon Linux base container. It runs security updates. It installs, most importantly, the ImageMagick package, which actually provides the convert binary that we're using to convert images from images into PDFs. It installs the convert worker script, which is actually the script that is doing the work, and then we're telling the container that the entry point, the script that it should be using when it starts, is this actual convert worker script. So let's take a look at the convert worker script. Also quite simple here. What we're doing is we're echoing out some environment variables so we can go back on the logs and understand how this whole thing ran. But what we're seeing here is we're taking some environment variables and variables that were passed to us automatically through the batch service. We copy the image from the S3 bucket to the local container that we also convert the image, just like we did in the previous example, from the image into the PDF. We then copy that PDF back into the S3 bucket and we clean ourselves up. So it's a quite simple use case. But do note, in this case, what we're doing is we're taking advantage of the array capabilities of batch. So what we're doing is we're actually telling this job to look up to see which unit in the array, which index in the array this particular job belongs to. So this job is able to take from the environment which is passed to it as this environment variable to understand which unit, which compute unit it is that it is working on. And so this case, what we're doing is we're numbering the images, we're prepending the images with the index, and then we're providing an array, job array into AWS Batch to execute on that. So let's see how this works from the console. So I've built this container already. I've submitted this container into AWS, the container registry service, so that I have that container already stored and ready to go. I've pre-populated my AWS S3 bucket with 100 images here that all need to be converted, right? So this represents 100 units of work. And the way that we'll do this is we'll submit a single job in AWS Batch as a job array, and then the job array will understand that it needs to execute across each of these images to be converted. So if we go back to the AWS Batch console, we can see our compute environment, which has been stood up here. It is defined as an unmanaged compute environment. It's in a valid state. It's enabled. I've set up a job queue. This job queue, if we look at it, is tied to this compute environment, right? So we can see that this particular job queue is associated with this compute environment. And we have a job definition, and I'll walk you through what this job definition looks like. So this job definition basically is defining what the environment looks like. I'm telling it each worker unit needs 2 vCPUs and 2 gigs of memory, and there's not much else here, right? So we can see what this looks like from a JSON perspective, and it's also pointing at the Docker image that we're going to use, right, which is the one that I showed you that we built earlier and pushed into ECR, which is the one that is going to do the actual work, which is the conversion from image into PDF. All right, so let's go ahead and take this and submit it as a job. So what we'll do is I'm going to go back, and to save time, I'm going to clone a job that I had previously run. And so in this case, what we're going to do is we're going to name the job. We're going to tie it to the job definition that I just walked you through. We're going to tell it which job queue to use. Here we're going to define a job type of an array. And remember I said we had 100 images. I'm going to say the array size is 100. Everything else we're going to pretty much leave alone. We'll let it just take, we'll take the defaults that we had already provided in the job definition itself. And then finally, a couple of important environment variables. We're going to provide the baseline for the image name, right? So remember, each image is actually prepended with one of the items in the array. We're going to tell it which S3 bucket the images are stored in, and we're going to tell it which region this S3 bucket lives in. So let's go ahead and submit this job. And so what's going to happen is this this job will be submitted, and we can see it has an array size of 100, and we can see that it's currently sitting in the submitted state. So if we refresh, we'll see that this job has now moved into the pending state. It's essentially moving down the line here in terms of what the next steps are. And eventually, what will happen is these will move into the runnable state, into the starting state, finally running, and then either failed or succeeded. In our case, we hope that they go into the succeeded state for the purposes of this demo. So what we can see is this will work its way through. And as it works its way through from a job completion perspective, we'll be able to go back and we'll be able to see that the jobs themselves took the data out of the S3 bucket, the S3 bucket that I mentioned here. They'll download each of the images, again, understanding how to know which image to grab based on the index array environment variable. They'll take them out, convert them from, in this case, PNG into PDF, and then push them back. So let's go ahead and back here and just understand where we are in terms of the job itself. Okay, here we go. All right, so those jobs have been submitted and they're sitting in the pending state. And so what we can do is we can head back to the S3 console and refresh here. And sure enough, we can see that those jobs have begun to run, and we can see that each of the images has a corresponding PDF associated with it. So the batch scheduler is working its way through each of these images, checking them out, running the jobs, and then submitting uploading the PDFs back into the S3 bucket as they complete their work here. And so, we can also go back. We can take a look in the succeeded tab, and we can understand the process of how the jobs worked, and we can dig into the logs a little bit more and just sort of understand, how the whole thing did its thing. And these logs show up in CloudWatch logs, and so you can walk through them and figure out. I like to be very verbose in my jobs and echo out lots of things, but we can see that the jobs were downloaded, converted, and then uploaded back into the S3 bucket. So I'll just go back over here and do one more refresh, right? So we can see that these jobs are working their way through. All right, so I'm going to head back here to my presentation. So just to sort of summarize, AWS Batch, right, fully managed, integrated with AWS, cost optimized, resource provisioning, especially with EC2 Spot instances. So very easy to use, very powerful. And at this point, I'd like to jump in to see if we have any additional questions that I can answer for us here. Here's the links as I said I'd provide. By all means, give Spot instances and AWS Batch a try. Here are the links to the demos. And now I will head over to the moderators and see if there are any questions that I can answer here.